Hello everyone, welcome to Computer Aided Analysis Laboratory. I am Rakesh VALASA. In this video lecture, I am going to explain how to solve the plane truss problem in Ansys 19.2 Mechanical APDL on Windows 10 platform software. Then experiment number 3, name of the job is plane truss. The objective is to determine forces and stress for the given plane truss. Here the diagram is given that this is the plane truss. It having two elements. Uh, each element having that two nodes. This node 1 and node 2 fixed, and also he has given that coordinates. Node 1 coordinates 0 comma 0, node 2 coordinates 0 comma 40, and node 3 coordinates 40 comma 40. These elements cross-sectional area is 200 mm square. To convert into meter square, that is 200 into 10 power minus 3 whole square. Here length is also you can convert into meters, so 0 comma 40 into 10 power minus 3. Next, two forces are given that one is horizontal force 500 newtons, one is vertical force 300 newtons. Both are acting at node 3. Let us see how to solve this problem in Ansys 19.2 software. First open Ansys 19.2 Mechanical APDL or product launcher. We know that first do the few must and should to follow the 3 steps. First one is go to the utility menu, click file and choose clear and start new. Here choose do not read file, then click on OK. Second step is file, change job name. Here the job name is plane truss. Plane truss. Then click on OK. The third step is file, change title. You know that title name is static analysis. Static analysis. Then click on OK. Next go to the main menu. First one preferences, structural, OK. The second step preprocessor, element type, add, edit, delete. Now click on add, choose link 3D Finite STN 180, then click on OK. Now close this window. The next step is material properties, material models, structural, linear, elastic, isotropic. Here the both elements having same Young's modulus, that is 200 GPa, 200 into 10 power 9 Newton per mm, 200 into 10 power 3 Newton per mm square. To convert into meter square, that is 200 into e power 9. Young's modulus 200 E9. Poisson ratio, you know that take default value, that is 0.3. Then click on OK. No need to create metal model number 2 because both elements having same Young's modulus and Poisson ratio. So you can create only one metal model number. Then close this window. Next go to the sections. Link. Click on add. Uh, Take ID number 1. Then click on OK. Section name 1. Here both elements having same cross sectional area, that is 200 millimeter square. To convert into meter square, that is 200 into 10 power minus 3 whole square. That means 200 e minus 6. This is 200 e minus 6. Then click on OK. Next move to the modeling, create nodes, inactive CS. First node number 1, that is 0 x0 y0, apply. Next node number 2, x0 and y is 40 e minus 3. 40 e minus 3 to convert into meters. He has given that 40 millimeters to convert into meters. 40 e minus 3. Then click on apply node number 3. That is 40 e minus 3 comma 40 e minus 3. Then click on OK. The next step is elements auto number throw node join, pick 1 and 3, apply, next pick 2 and 3. OK. Next step is add loads. Go to the loads, analysis type, new analysis, static, OK. Next define loads, apply structural displacement on nodes. Here node 1 and node 2 are fixed. Then click on apply, choose UX and UI, then click on OK. The next step is apply the force or moment at node 3. Next, force or moment on nodes, choose node 3, apply. In the x direction the force is 500 newtons, apply. Next again choose this point, apply. Uh, change direction Fi. In the Fi direction the force is 300 towards upward direction, so that take positive, then click on OK. Now capture this image. Report generator, append OK. This name is you can plot elements. You can capture this image. This name is plane truss with boundary conditions. With boundary conditions. Then click on OK. The next step is go to solution, solve current LS, then click on OK. Now the solution is done. Close this window. Next go to general post processor, plot results, contour plot, nodal solutions, DF solution. Here you can choose X component or Y component, that is your wish. Here I am choosing X component. OK. You can capture this image. This is nodal solution in X direction. Nodal solutions in X direction. OK. Now you can also capture Y direction. Y component of displacement, then click on OK. Now also capture this image. This is in Y direction. Then click on OK. Next go to the you can also capture deformed shape, deformed place, undeformed shape. OK. This name is deformed shape. Then click on OK. Next go to the element table, define table, click on add. First item is force. Scroll down, choose by sequence number SM ISC comma 1, apply. Second item is stress, by sequence number LS comma 1, apply. Third item strain. Scroll down, choose by sequence number LEPL comma 1. OK. Now close this window. You can also see the list element table. Choose force, stress, strain. OK. You can note down these values in your LMRB. Then close this window. Next go to the plot results, element table, force. OK. You can capture this image. Next stress, Okay, capture this image. Next, strain. Okay, capture this image. Line element results. Force, okay. Capture this image. This is the force. Okay. Next, line element results. Both nodes are stress. Okay. Capture this image. This is the stress. Then close this window. Okay. Line element results. Strain and strain. Okay. Capture this image. This is strain. Okay. Next, element table. Element solutions. uh, Contour plot, element solution. You can also capture this image, stress x component. Okay. Next, go to deformed shape. uh, you can capture any image that is asked in LMRB, otherwise you can leave it. Next, you can also see the animation, plot controls. uh, you can change the style, size and shape. You can turn on display of element. Okay. Plot controls, animate, mode shape. Okay. You can see the deformation for plane truss. Stop and close this window. Now the last step is HTML report assembler. uh, Report heading, title is static analysis. Static analysis. Next, author name is, type your name. Subtitle, plain truss. Okay. Now add those captured images. Okay, finally you have to click preview report. Okay, due to compatible issue it is not opening. Don't worry, you can go to the folder Ansys 2024, folder name plain truss report. Open this HTML file. To convert this HTML file into PDF, just you can click Ctrl P and click print. Save in your save in your PC, then share to your mail and take the printout. Okay, this is the way to solve the given plain truss problem in ANSYS 19.2 Mechanical APDL version. I hope this solution is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more updates.